Use the sample data and confidence level given below to complete parts A through D. A drug is used to help prevent blood clots. In a clinical trials among 4,721 patients treated with the drug, 129 developed nausea. Construct a 99% confidence interval for the proportion of patients who develop nausea. So first, we want to find the point estimate of the population proportion. The sample proportion is the best point estimate of the population proportion, and we can find that using StatCrunch. Let's open up StatCrunch. Since we are working with population proportion, we are going to go on stat, proportion stat, one sample with summary. We don't have the data. Number of successes, in this case, we are interested in the number of people who develop nausea. So in this case, 129 people develop nausea. From number of observation, there's 4,721 patients. Select confidence interval for P, and we're doing a 99% confidence interval. Once you click compute, you will get your sample proportion, which is the best point estimate of the population proportion. Rounded to 3 decimal places, it's 0.027. Next, we want to find the margin of error. So we have the lower and upper limit of the confidence interval, and sample proportion is right in the middle. So the margin of error is the distance between sample proportion to the lower limit or sample proportion to the upper limit. So we can do the difference between sample proportion to the lower limit or sample proportion to the upper limit. So I'm gonna go ahead and find the difference between sample proportion to the lower limit. 0.027324719 minus, so sample proportion minus the lower limit, 0.021213022. That distance, it's called the margin of error. Round it to 3 decimal places, you get 0.006. Next, we want to find the confidence interval, and you have the confidence interval right here. Make sure you round your answers to 3 decimal places. So I have the lower limit as 0.021, and the upper limit is 0.033. So basically, this means that we are 99% confident that the proportion is going to fall between these two numbers. So one has 99% confident that the interval from the lower bound to the upper bound actually does contain the true value of the population proportion.